Okay, this video is going to cover section 6.4, which is proportions. So we're going to get a little bit more in depth into proportions, kind of look at some word problems. So in this one, we've got, suppose two adults produce 63.4 pounds of garbage in 1 week. At this rate, how many pounds of garbage will 50 adults produce? So what we want to look at is we want to look at the numbers with the labels. So we have two adults, and they produce 63.4 pounds of garbage. So let's start with that. So I have two adults, and I'm going to use my labels. And they make 63.4 pounds. Okay? So when I set up my second piece to the proportion, I'm going to go ahead and use the same labels. The top should be adults, and the bottom should be pounds. Okay? So then when I go back through the problem and I'm looking at the last piece that they give me, I have 50 adults. So that means my 50 has to go on the top to match my labels, and my X needs to go on the bottom. So your labels should be the same all the way across. And if you do it that way, then you're going to be able to cross multiply and have the right solution. So this is going to give me 2x when I cross multiply, and 50 times 64.3 is going to give me 3,170. Okay? So then I just finalize the problem by dividing by 2, and x is equal to 1,585, and I'm looking at my missing label, which is pounds. Okay? This one's a little bit harder because they're using feet in both. So I'm going to use just feet for the actual distance. This is the actual height of the flagpole is 15 feet. And this one talks about a 4-foot shadow. So I'm just going to write 4, and then I'm going to write shadow. So I know what I'm talking about here. So I know that I need the actual feet on the top, and I need whatever the shadow's length is on the bottom. So how long will the shadow be for a 90-foot building? 90 feet is the exact height, so we're looking for its shadow. So again, we're going to cross multiply. This gives me 15x, and over here we have 90 times 4, which is 360. And then I can divide both sides by 15. So x is equal to 24 feet. It's still feet, but we know that this is the shadow. So you can write 24-foot shadow or just 24 feet. It's the same thing. Okay, if you want to pause and try this one on your own. So we have 3 pounds at 450. And that means that I need pounds on the top and I need dollars on the bottom. So it gives me 7 pounds. So I'm put 7 on the top and x on the bottom. So 3 times x is 3x. That's not a 31, that's a 3 pounds. And a 7 times 450 is 31.5. Okay, so then I'm going to divide by 3. And x is equal to 10.5, so I'm going to add a 0 to make it money. It's $10.50 for 7 pounds. Okay, again, if you want to pause it and try it yourself. So in this one, we've got a certain map. The distance between Shreveport, Louisiana and Memphis, Tennessee is represented as 4.5 inches. The actual distance is 288 miles, so that's enough to get us started. So I have 4.5 inches over 288 miles. So I need anything that's in inches on the top and anything that's in miles on the bottom. So what they tell me is that the map distance between Seattle, Washington and San Francisco, California is 11 inches. So my 11 goes on top and my x goes on the bottom. So cross multiply now. We have 4.5x is equal to 11 times 288, which is 3,168. We can divide by 4.5. So this cancels. I have my x, and this divided gives me 704 miles. So the actual distance on the map is 704 miles. Okay? So what we also have, because we have ratios and proportions, is that we have similar figures. So two triangles, I'm going to say polygons. Polygons are shapes that have multiple sides, any sides. So a square, rectangle, anything's called a polygon. Whose corresponding sides are proportional are called similar triangles, or we can call them similar figures. I call them similar figures a lot. So what we can do is we can look at this and I can show you how this works. So if I look at the corresponding sides means if I'm looking at this side in this triangle, it corresponds to this side in this triangle. They're in the same position. So I could write this as a proportion, 3 to 6. And note, I'm always going to move left to right, not smallest to largest, but left to right, just like regular things that we do. When I reduce this, I end up with 1 over 2. So my ratio would be 1 to 2. I can look at this bottom piece, which corresponds with this bottom piece, write it as a ratio, 4 to 8. And again, when I reduce it, it's 1 to 2. Okay, and finally, I could check out these. This hypotenuse is corresponding to this hypotenuse, right? Or this diagonal, however you want to call it. And this is going to be 5 to 10. And again, it reduces to 1/2. So that means that this triangle right here is exactly half the size of the larger triangle. So that's why they're called similar. So we can set up proportions to find missing pieces in similar figures. So let me show you in the next example how this works. And these triangles, they're telling me that they're similar. So all I have to do is say that they're similar. As soon as I see that word, I'm good to go. And then I can set up proportions to solve for missing pieces. So here I have a complete triangle. And again, remember, we want to move left to right always. And I have some missing pieces on this triangle. So the first thing I want to solve for is x. So in order to set this up as a proportion, I need to find two pieces that are already complete on my triangle. So my two corresponding bottom pieces, they have the information. So I'm going to set up my proportion with 2 to 5 equals. So then I want x. So I look on this piece and I see that 2.3 is the same side on the triangle as x. So I set it up as 2.3 corresponding to x. So when I do that, I'm able to now solve the proportion to figure out what x represents. So I have 2x and I have 2.3 times 5. Well, 2.3 times 5 is going to give me 11.5. So now I divide by 2, and x is equal to 5.75, and this was feet. So that means that on this triangle, this side is really 5.75 feet. Okay? So now I want to do the same thing solving for y. So if you want to pause it and try y, that would be a great idea. So I'm going to start still with my 2 to 5 as my ratio. Then I need y. So 2 corresponds with y. So I'm going to have 2 over y. So here it'd be 2y, and here 2 times 5 is 10, and if I divide by 2, y is equal to 5 feet. So that means that this side is really 5 feet. Okay? So here's one you guys can try, not that one, let's try this one. So in this one, I want you guys to try this one just to see that there are different shapes that you can use. So all I have to do is say that it's similar, which it is, and then I'm ready to set it up. So I'm looking for a corresponding side that's the same. Again, we're moving left to right, not smallest to largest. So this time it's going to be 10 to 5 is equal to, I need this side right here over this side here. So x to 3. So this time x is on top, works the same way. 10 times 3 is 30, and 5 times x is 5x. If I divide both sides by 5, x is equal to 6 inches. So that means that these sides right here, this is 6 inches on this rectangle. If you have any questions, please contact me.